All right. In the last lecture, we had started mathematical expressions. By the expression, we mean that it can be a value like 2, 5, 7, and so, or it can be a variable like height, number, whatever we have the variables, or it can be a combination of these in a mathematical expression like we can say a plus b divided by c times 4 plus 3 and so on. So this will be also will be an expression. And we can use expressions to assign a value to a variable, or we can use them to print. Like we don't need to give only always a value or a variable. We can also write an expression and then its result will be printed, or we can also use them as an input to the parameters, like, and then the result will be given to as a parameter to the input. Like math square root basically takes the square root of a given number. So I can write here 8, or I can write here 2 plus 6, and then the result will be same. So basically, whenever we need a value, I can put there the value itself directly, or I can put the variable that keeps that value, or I can just have an expression in which the result will be some kind of a value, and then the value will be processed accordingly. And we had also seen that we can use integers and the floats to do these expressions. Even though they are different data types, it is still valid. But when we are doing some conversion data, from when we are converting floating value to an integer, then we should be more careful about it, because we might lose some of our data. Like if our floating value is 2.6, then if we convert it to integer, then we will keep it as an 2. And if we convert it back to float number, then our value will not be anymore 2.6, but it will be 2.0. So we will actually lose some of our data. It's not exactly the same value now. So so in short, yes, we can do these type of conversions, but we need to be careful about it and check if our calculations will be still valid. And this was the slide that we couldn't cover in the last lecture, so we will continue from here. Now, when we are writing expressions, sometimes it might be very long. Maybe the formula is very long, so we have to write many things. But then the problem here might be is that, like, if I need to write my expression in one line, then if it is too long, well, probably I will not be able to read it. Like, let me open my, for instance, our Python screen. Then let's say that I want to write an expression here, like it will, let's say 3 plus 5, and then I will just do copy paste to make it faster. Then when you see that, okay, now I'm going back, actually my formula is much longer, as you can see, but I'm not able to read that. So what you might want to do is, well, okay, maybe I can break it down to multiple lines, like let's say this, so that at least now I'm able to read it. But the problem here is that now when I did this, my Spider software immediately showed me that this is invalid. This is not a valid syntax, because now I'm trying to write something in multiple lines and Python does not allow it. But putting them in one single line makes it unreadable. So there's one solution. There are two solutions for that. One of them is, at the end of this line, I can put this sign, this slash sign. Then, as you see that this red warning sign is disappeared. Now this is a valid statement, because now Python says, okay, once you put this slash sign, then it will show, Python will understand that, okay, the next line also belongs to this expression, so it will be able to run it and will not make it a problem. But just know that, yeah, we have to put this very specific, it has a very specific notation, we have to put this slash signs. So this is one way. You can also do it with another way, in which, again, when I deleted it, I check that it just gives me the warning again. If I put them between parentheses, like I open the parentheses, then I'll write my expression, and then I'll close it then. Then again, my warning disappeared again. So I can also put this multi-line expression in between parentheses, then I don't need this slash sign. So then I can write it as many lines I need. Like maybe I can find that, okay, this is also not so readable. So I want to, and I need to continue with my expressions and so on. As long as it is between parentheses, then that would be fine for Python, that we can write it in multiple lines. This is just about readability of an expression. Sometimes it can be too long, so that's why we might want to put them between either parentheses, or we can use this slash sign to be able to write a multi-line expression. Shall I proceed? All right. This is just a warm-up questions. I want you to answer this, but every time I want another student to answer that. Okay, so if you answer one of them, then please, you can still solve it, but please be silent. So we want to know what is the value of x after each of these expressions, like 2.0 divided by 4. What is the result? Half. So in mathematically, what do we say? 0.5. Yes. How about 4 divided by 8? Another student? 4 slash 8. What is the result? Same. How about the next one? 4 double slash 8. What does it mean if we use two slash signs? Yeah, then it will be an integer division. So in an integer division, what we do is we remove all the decimal parts. So normally 4 divided by 8 should be 0.5, but if it is an integer division, I remove this 0.5 part, so the result will be 0. So if I use double slash, it will be 0. Then how about this one? Can anyone tell me 4 plus 8 divided by 2 minus 3 times 2 modulus, or remainder 2? What is the answer for this? Yes. Yeah, you started in a good point. Yes, we have to first identify the priorities, and you were right that yes, the multiplication has a higher priority, and also division and also remainder. They have all higher priority than addition and subtraction. So yes, we have to start with the division and also multiplication remainder. The result it will not change, but yeah, we have to first do this. 8 divided by 2 is 4. Okay, I'll keep it in mind. So 4 plus 4 minus, now I have to do this part because this also has multiplication and modulus. 3 times 2, 6. When I divide 6 by 2, the remainder will be 0. So this part will be 0. Then 4 plus 4, 8 plus 0 is 8. And how about this last one? I have this integer function which basically converts float number to integer. And then 3.0 divided by 2. What will be the answer? 1.5 will be the result of our division. So, but when I put 1.5 to an integer int function, it will convert it to an integer value, but it will be only 1. So the result will be 1 in this case. Is that understood? Shall I proceed? All right. Then the named constant. So what is this? In programming language, when we say that a constant variable, it means that the value of that variable, once it is assigned, you cannot change it. So the programming language should not allow that. It shouldn't be reassigned. What I mean by that is, let's say I have this variable x here, then I said that it is 5. And then if it was a constant, then when I try to reassign another value, I should get an error message. Now the thing is, this in some languages like Java, they have this constant variables. What I mean is that you define a constant variable, put a value in that, and then afterwards you can never change it. If you attempt to change it, you will get a compiler error. The code will not run. But Python does not have it. So in Python, actually, we cannot define a constant variable. Always, when I define a variable, whatever I do, I can always change it. Like I can first assign it to 5, then 7, then even to a string value. So Python does not have this feature. But in programming, this is actually an important way, in a very practical way, because some values should not change. Like let's say that mathematical pi, like it's always 3.14 and so on. So when I define this pi, and I'll say that okay, pi should be 3.14, then I should not be able to change it to say that okay, pi is now, there's a mathematical revolution, so now it is from this time it will be 6. I should not be able to say this. This should be meaningless. So for some of these cases, we need constant variables. Like maybe you are implementing some application for a company, maybe an e-commerce platform, let's say, and then there's a tax rate. And for that tax rate, maybe you said that okay, it should be this 0.0675. Then another software developer might come, if it is not constant, might change it. Like, okay, the tax rate now, I want to make it 0.1. If we allow that, well, there might be really big problems for the company because you just played with the tax and then you mess up all these financial calculations and so on. So we don't want this to happen. Now, the challenge with Python is that Python does not have this rule. We can always change these rules. We can always change a value of a variable. What we have is convention. This also exists in other programming languages. In programming, we really pay attention to tradition. We are really traditionists in that sense. Because what does it mean is, we want to write code as the other people do. Just to reduce the complexity of our code. Like when I write a code, okay, I want others to be able to understand it, okay, so that they need to read it and they have to understand it. But then that's why we want to follow these conventions. Like we give meaningful names. Like even though the code runs, if I just give meaningless names, it will run. But well, we said, okay, no, give really meaningful names. It is really important for us so that we can read it. And there's also convention in coding about these constant variables. If I say that, if I write a variable name with all upper cases, like tax rate, but all the letters are uppercase, it means that I want this variable to be a constant, okay? I mean, theoretically, yes, you can change, like in Python, if I say tax rate is 0.5, then I can change it to this one. Yes, it is correct. But at least if I follow this naming convention and then I give my code to another person, okay, here is my code, you can read it. Or maybe he will update it, he will try to find this error in my code. He will see that, okay, this variable is all with upper cases. This means that, okay, this programmer meant that this constant should be, this variable should be a constant. So I shouldn't change it. I shouldn't change that thing because this is how he thinks that the program should run. So when I see that, okay, this is all uppercase, okay, I shouldn't change it. It just gives me a message that, okay, this is a constant value. The developer designed it to be a constant value, so I should not change it. So this is, again, just a convention, but it is a useful convention. If you want some value not to be changed, then you need to give we write the variable name with all upper cases. Well, you might say that, okay, why do I need a variable if I will not change its result? Like I said, number of students 40, okay? So why do I need a variable if I don't want to change its value? Like, let me say it in this way. For instance, I said I have this number of students is 40. And then probably I will use it in some place, like maybe I want to calculate the, I don't know, average GPA, okay? So maybe I have some total GPA at some point, maybe I calculated that, let's make it some value, whatever it is, okay? Then I want to calculate the average GPA, so I can say, okay, average GPA is total GPA divided by number of students. So this will give me the GPA. I want to say not GPT, GPA. Yeah. Okay. So this is how I can use this variable. But you can say, okay, since this is a constant, like instead of putting this num students, I don't want to change it. I could also say this. It will be 40 all the time. So why should I put a variable name on it? Like say the number of students is 40. Because if I don't want to change it, I can also hard code this value. They are both valid. Do you have any idea about why we need this kind of naming then? Like I define a variable with some value, but I don't want to change its value. It kind of contradicts with its name. I say variable, but its value is fixed. It doesn't vary. It is the same. The reason is, it has two reasons. The first one is, if I write this code, total GPA divided by 40, okay, then it will reduce the readability of my code. Like maybe 2 weeks later, you will come and say, okay, why are we dividing it by 40? What is 40? I don't know what is 40. Okay, you might forget it. Or some other people might not know what 40 means. But if I write it like this, total GPA divided by number of students, then they will understand, okay, they just want to calculate the average. So they don't care what, they don't need to know what 40 is. So this is one. Second thing is, well, maybe it was a constant, but some things have changed. And then the number of students, maybe another student enrolled in, and it became 41. Okay? So I need to rerun my code and redo the all these calculations. But the problem here is that if I had used this 40 in my coding, and if I use this number of students in many places, let's say that I have a code with 1,000 lines of code, and then I use this number of students value in 10 different places, then I should change all these 40s to 41. And well, I can do it, but it will be time consuming. I might miss something that in some place it might remain 40 and in some place in 41. So I'm trying to reduce the likelihood of doing my mistake. So what I can do is instead of changing all 40s to 41, if I give it a name like this num students, I just need to change it in one place. Now it is not 40, now it is 41. So I don't need to go over all these 10 different locations and change it to 40 to 41. I just need to change it in one place. So that is also a better way of writing a code. So if you need a constant variable, constant value, so in short, if you need a constant value, give it a name, write all, but the name should be all upper cases, then that would be a better coding style.